Okay, so in this video we are going to be looking at the product rule. But before we do that, I thought we'd do some recap questions and just look at how to differentiate these using the chain rule. So in question A, we've got y equals -2 bracket 3x minus 7 to the power of 8. So we're going to use the chain rule to do this. So y dash is equal to, we're going to bring down the power and multiply it by what's in front. Minus 2 times 8 is -16. So write everything inside the brackets as it is. I'm going to reduce the power by 1. And then we're going to times this, so that's the dot product, by the derivative of what's inside the brackets. So we can differentiate that to the power, with respect to x. When we differentiate that, we get 3. And now we can just tidy this up. -16 times 3 is -48. Lots of 3x minus 7 to the power of 7. Okay, question B. I'm going to rewrite the question as y is equal to 5 lots of 2x plus 9 to the power of -3. Okay, I'm just going to bring this up. So when we want to differentiate this, we have y dash is equal to, going to multiply the power up down. 5 times -3 is -15. I'm going to write down exactly what's inside the brackets. And I'm going to reduce the power by 1. Now -3 minus 1 is -4, so just be careful with that. And then we need to multiply that by the derivative of what's inside the brackets. When we differentiate 2x plus 9 with respect to x, we just get 2. So we've got -15 times 2 is -30. Lots of 2x plus 9 to the power of -4, or we can write that as -30 over 2x plus 9 to the power of +4. Okay. Today, we're going to be looking at the product rule. So by the end of this lesson, you'll be able to explain what the product rule is, how to identify when to use it, and actually use it. So what is the product rule? Suppose you have a function y equals u times v is a product of two functions u and v, each of which is a function of x. Then do y dx, or y dash, or the first derivative, or the gradient function, is equal to v times du dx plus u times dv dx, or y dash is just equal to vu dash plus uv dash. Now I like to use the second one. Okay. In your formula sheet, you actually have that version. So let me show you what it looks like. So here's our formula sheet. And if we want to scroll down to differential calculus, we've got it here. When y is equal to u times v, dy dx, or y dash, is equal to u times dv dx plus v times du dx. Now, I don't like to use this. I prefer it if you just memorize the one that I've highlighted here. Y dash is equal to vu dash plus uv dash. Now, please remember it in that order, because when we learn about the quotient rule next, it's going to be very similar. I'll just write it down here. The quotient rule, which is when we need to differentiate a fraction where both the top and bottom in terms of x, is y dash is equal to vu dash minus uv dash over v squared. Now the reason why I want you to memorize this is because this bit is essentially the same as the top, except it's a plus instead of a minus. Okay, so I want you to memorize that because the order is very important for the quotient rule. The quotient rule has to be vu dash first and then u minus uv dash. In the product rule, it doesn't matter which order it is. That's why I prefer it if you just remember the one order, vu dash first and then uv dash. Okay, so here I've got an example. If y is equal to 2x times 7x minus 2 to the power of 4, well then u is this bit, 2x, and v is this bit, 7x minus 2 to the power of 4. Okay, we can see that they are both in terms of x because u has an x in it and v also has an x. Whereas when we looked at the chain rules up here, if we were to assume that this is u and this is v, only v has an x. U does not have an x, so we don't need to use the product rule there. And here, if we assume that u is up the top and v is at the bottom, only v is in terms of x. There's no x with the 5. So we know we don't need to use the product rule here, or the quotient rule in that case. So, when do we use the product rule? We use the product rule when both u and v are in terms of x. So, question A, do we use the product rule? I might actually get you to just pause the video, just tell me whether we should use the product rule or the chain rule for A, B, and C. Okay, so let's have a look at your answers. So question A, if this is u and this is v, they both have an x, so yes, we use the chain rule. Oh, sorry, we use the product rule. Product rule. In question B, if this is u and this is v, only v has an x, so we use the chain rule here. Question C, we've got 2x times e to the power of x. Well, here's my u, 2x. Here's my v, e to the power of x. Oh, they both have x's. So, yep, we use the product rule. Okay, so let's actually use the product rule now. We won't actually look at, see this question C here. We've got exponentials. We'll learn about that in a different topic. How to differentiate exponentials. Okay, so let's have a look at the product rule. Differentiate y is equal to x lots of x minus 10 to the power of 4. So I'm just going to highlight everything. Here's my u, here's my v, and I'm going to write that down. So I'm going to write u is equal to x, and then I'm going to differentiate it straight away. When I differentiate x, I just get 1. I'm going to write v is equal to x minus 10 to the power of 4. When I differentiate this, I'm going to use the chain rule. Bring down the power, write everything the same in the brackets, reduce the power by 1, and then times it by the derivative. What do we get when we differentiate x minus 10? We just get 1. So, we're just timesing it by 1, which is exactly the same as what it is. So I'm just going to get rid of that. So that means y dash is equal to vu dash. So vu dash, I'm going to times these two together, which is just x minus 10 to the power of 4, plus uv dash, I'm going to times these two together. So that's 4x lots of x minus 10 cubed. Now I'm just going to tidy this up because I can see that I can factorize out an x minus 10 cubed. So I'm going to bring that out to the front, x minus 10 cubed. That leaves me with an x minus 10 for the first term, plus 4x in the second term. Okay, let's tidy this up. So that gives me x minus 10 cubed. X plus 4x is 5x minus 10. Let's factorize out of 5, leaving me with x minus 2. Okay, so that's for that bit. And then I've got my x minus 10 cubed there. Okay, question B. We have u is equal to x squared, so u dash has to equal to 2x. V is equal to 3x plus 2 all cubed. So v dash is equal to, bring down the power, 3x plus 2 reduce the power by 1, but we need to times it by the derivative. Okay, of what's inside the brackets. When we differentiate that, we get 3. So that's actually 9 lots of 3x plus 2 all squared. Okay, so y dash is equal to vu dash. vu dash, I'm going to times them together. 2x times 3x plus 2 all cubed plus uv dash. uv dash, and times them together. So that's 9x squared, lots of 3x plus 2 squared. Okay, I'm going to tidy this up. I'm going to factorize out a common factor of x and 3x plus 2 squared. That leaves me for this first term 2 lots of 3x plus 2. And for the second term, it leaves me with 9x. Okay. So let's just tidy this up. We've got 2 times 3x is 6x, plus 9x is 15x, and 2 times 2 is 4. Okay, pause the video, have a go with questions C and D. Okay, question C. We've got u is equal to x to the power 7. So u dash is equal to 7x to the power 6. V is equal to 2x minus 5. So v dash is equal to 2. So when we differentiate this, we get vu dash times them together. Plus uv dash times these together. Let's tidy this up. That's 14x to the power 7 minus 35x to the power 6 plus 2x to the power 7, which is equal to 16x to the power 7 minus 35x to the power 6. Okay, question D. We've got y is equal to 4x minus 1 times 2x cubed plus 3. So u is equal to 4x minus 1. So u dash is equal to 4. V is equal to 2x cubed plus 3. So v dash is equal to 6x squared. So y dash is equal to vu dash. vu dash, those two times together, which is 4 lots of 2x cubed plus 3, plus uv dash, these two times together, which is 6x squared times 4x minus 1. Let's expand this out to tidy it up. We've got 8x cubed plus 12 plus 24x cubed minus 6x squared. That leaves me with 32x cubed minus 6x squared plus 12. Okay. Question E and F. I'll get you to pause the video, see if you can give this one a go yourselves. If not, I'm happy for you to just watch on. So question E, u is equal to 3 minus x. So u dash, when we differentiate this, we get negative 1, right? Negative 1. V is equal to x plus 1 to the power of half. V dash, going to bring down the power. Right, what's inside the brackets? Reduce the power by 1. And then we are going to multiply this, because we need to use the chain rule, by the derivative of what's inside the brackets. When we differentiate that, we get 1, which is exactly the same, so we don't really need that. Okay. So, y dash. The derivative is equal to vu dash. I'm going to multiply this one with this. Negative x plus 1 to the power of half plus uv dash, this times this, half times 3 minus x times x plus 1 to the power of negative half. Now I'm just going to rewrite this as a third, just to make it look a little bit neater. We've got negative the square root of x plus 1 plus 3 minus x over 2 lots of the square root of x plus 1. Okay, so we can see here that this negative half applies to this, so it goes to the denominator of the fraction with a positive power of half, or just means the square root. Okay. Now, I might want to make this have a common denominator of 2 root x plus 1. So if I were to multiply both terms, both this, if I were to multiply this by 2 root x plus 1, that's going to give me a negative 2 lots of, root x plus 1 times root x plus 1 is just x plus 1. Plus 3 minus x, and now that's all over a common denominator of 2 root x plus 1. We can now expand the brackets and collect like terms. So we have negative 2x minus 2 plus 3 minus x all over 2 root x plus 1. And that's just going to give us a final answer of minus 3x plus 1 all over 2 lots of root x plus 1. Okay, let's have a look at question F. U is equal to x squared plus 5, so u dash is equal to 2x. V is equal to 8 minus 3x to the power 4 all to the power 6. So V dash is equal to, bring down the power, 8 minus 3x to the power 4, reduce the power by 1, times by the derivative. Now, when we differentiate what's inside the brackets with respect to x, we get negative 12x cubed. So I'm going to multiply that out. We've got negative 72x cubed, lots of 8 minus 3x to the power 4 to the power 5. Okay, so the derivative, y dash, is equal to vu dash, these two times together, which is equal to 2x times 8 minus 3x to the power 4 to the power 6, plus uv dash, which is negative 72, excuse me, I'm going to get rid of this plus sign, negative 72x cubed, x squared plus 5, 8 minus 3, x to the power 4 to the power 5. Okay, let's tidy this up. So I can see that they both have a factor of 2x, as well as 8 minus 3, x to the power 4 to the power 5. So what's left over? For the first term, we can see we've got 8 minus 3, x to the power 4 left over. For the second term, we'll put a minus. 72 divided by 2, we got 36x squared. Lots of x squared plus 5. Okay, let's tidy this up. 16, we're not going to expand that. 2x bracket 8 minus 3 x to the power 4 to the power 5. We've got 8 minus 3 x to the power 4 minus 36 x to the power 4 minus, what's 36 times 5? 180 x squared. Alright, so that leaves us with 2x, 8 minus 3 x to the power 4 to the power 5, times, we've got negative, we'll just write 8 there, negative 39 x to the power 4 minus 180 x squared. And that's it. Thanks everyone.